Let's go back to the students who are with Asanda and see if they're keeping up with us so far.
Hey Alfie, what's happening?
Nothing.
You good?
Yep.
Okay, so tell me a bit about yourself.
Oh no, normal, do martial arts, study investing. Yeah, I'm not the average teenager at all. I don't really like taking things fast, just like to relax, so I'm quite lazy. Yeah, that's
Okay.
Alfie.
Well Alfie, you've got something you want to clear up with Honor, don't you?
Yep. Look, it's not volume as we thought, but it doesn't seem so difficult, at least not so far.
If you completed a table of values for your investigation, then I suspect your results will look something like this. You will have recorded length, breadth and height. And because you used 48 cubes to make each of the rectangular based prisms, you'll expect the volume to be 48. Now, if you look at each of the columns in your table, did you notice something? 2 times 4 is 8, and 8 times 6 is 48. 2 times 3 is 6, and 6 times 8 is 48. 3 times 4 is 12, and 12 times 4 is 48. And 2 times 2 is 4, and 4 times 12 is 48. Now, to be fair, we shouldn't really be surprised by that observation, because if you think about it, that's how we were introduced to multiplication many, many years ago. Let me show you what I mean. Here I have an arrangement of the 48 cubes. And let me now pick up this layer over here and put it down over there. What I have is one layer with 24 cubes and another layer with 24 cubes. If I want to know how many cubes there are in the original rectangular prism, I'm really saying 24 plus 24, which is 2 times 24. And that's effectively what we're doing. We're saying how many cubes are there in each layer of the prism and how many layers are there in the prism. I hope that's all making sense so far. Now, to make sure that it really makes sense, I want to go back to that arrangement of cubes one more time. What I need you to realize is that the number of cubes in a layer of the prism can change. In this arrangement there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 cubes in each layer. But in this arrangement over here there are 1, 2, 3, 4, 5, 6, 7, 8 cubes in each layer. The point that I'm trying to make is that our way of determining the volume of an object should include a way of determining the number of cubes in each layer. When we look at the prism from above, the top view if you like, then you should see that you can't actually see the cubes. All that you can see is squares. And what does that remind you of? Hopefully it reminds you of area. The number of squares in a row times the number of rows. If you like, I can now write up the formula for the volume of a rectangular prism as follows. We can say the volume is equal to the area of the base multiplied by the height. The area of the base is the number of cubes in each layer, and the height is the number of layers. Now, in the case of the rectangular prism, we know that the area of the base is given by length times breadth. And we know that the height of the prism is given by height. The volume of the rectangular base prism is length times breadth times height. Now, before I show you that we have effectively found a formula for determining the volume of any prism, irrespective of the shape of its base, I suggest that you do a few problems. Let's quickly go and see how the students feel about the way that this lesson is developing.
Okay, Arno, Adam hasn't gotten enough of you because he's back for another question. But before we get to your question, I just want to find out, how's everything going with the maths?
So far, quite well. I've been studying hard.
You ready for the exams?
I hope so.
Just clearing up a few last moment things.
Yes.
Arno's right there.
We have already determined the formula for volume of a rectangular prism. Yet already you say that we can determine the volume of a prism of any shape. Could you please elaborate on this and show us what you mean?
Well, Arno, could you?
Of course I will. Let's go back and make sure that all of this is clear. What we've done is the following. We've argued that the volume of an object is effectively the number of cubes in a layer multiplied by the number of layers in the object. Then we made a very smart realization. We said that the number of cubes in a layer is effectively the area of the base of the object. Let me remind you of that one more time by picking up this object and putting it in here. Remember, you can't even see that this is 4 cubes high. All you can see is squares, an area. I've summarized that then to say the volume is equal to the area of the base multiplied by the height. Now, when the base is a rectangle, as in the case of a rectangular prism, then the volume becomes length times breadth times height, because the area is length times breadth. So this is the volume for a rectangular prism. But what about a cylinder? That is, what if we had a base that was a circle? And on that we built our solid. Well, then the volume would be the area of the circle, which is pi times r squared times h, the number of layers. In other words, that is the formula for a cylinder. And what if we had a triangular based prism? That is, we had a prism with a base that looked like that. Well, once again, its area, that is the area of the base, would be 1/2 times the base times the perpendicular height multiplied by the height, the number of layers in the prism. And there we have the formula for a triangular based prism. Isn't it fantastic how powerful you become when you just spend a few moments thinking about what you're doing? It's time for you to try a few more problems. And with that, I think we've come to the end of our study of measurement. Till next time.
Well guys, that's it from us. I'm going to hang out with Adam for a while. While we do that, you study hard and I'll see you next time. Bye!
Bye.